Hey, Comets. Welcome to the first of what will probably be quite a few of these little mini lessons that I'm going to be posting here in the next coming weeks. This week, we were mainly just wanting you to focus on that packet, whether you got it virtually or you picked it up from one of the locations. The idea here is review, and I know it's been a while for some of you since you've looked at material like this, and if your parents are watching, it's probably been maybe even longer since they've seen some of this stuff. So this video is just is intended to be a help, a resource, to help you get through some of those sticky spots on each of the pages. We're not going to do all the problems together, but at least enough hopefully to get you through so you know how to do the rest of the problems. So with all that, we're going to go ahead and go to the first page, at least that has content on it. Looks like this. Okay, so it's talking about writing the prime factorization for each number, then determine the greatest common factor. So in my opinion, that is two things, two different standards. Prime factorization is what we're going to look at first, all right? So in the worked example, you can see they have 18 and they have 42, and they take 18 and they split it up into two factors. Remember, factors are what you multiply together to get the number, okay? So you can multiply 3 and 6 together and get 18. Now that's not the only possible thing you could do. You could do 2 and 9, okay, but we aren't going to use 1 and 18 because 1 doesn't help us at all, right? It's not a prime number. It's not very helpful. So try to use numbers other than 1 if possible, okay? If you can't use a number other than 1, then you know you're done, okay? You found a prime number, all right? So 3 times 6 gives us 18, and then 3 is done because there's no two numbers that multiply together to give me 3. 6 is not done because 2 times 3 would give me 6. So the prime factorization of 18, as they say over here, is 2 times 3 times 3. All right? And then 42. We split 42 into 7 times 6, and then 7's done. All right? And then 6 is 2 times 3. So listing it out, it's 2 times 3 times 7. Okay? So that's part 1. Okay? That's this sentence of the instructions. If you have this written out, you have the prime factorization of each number. Then, to use that to find the greatest common factor, we look at all of the prime numbers that are used to build 18 and all the prime factors that are used to build 42, and we look at where there is some numbers in common, okay? Hence the word greatest common factors, right? So 2 and 3 appear in both of these prime factorization lists, okay? So 2 and 3 must be in both 42 and 18, okay? It's kind of like in their DNA, if you will. Okay, 3 and 7 are not something they have in common, because this has a 3, this has a 7. That DNA is not the same, okay, if you want to look at it that way. So 6 and 6 is our GCF, our greatest common factor, okay? Now another way to look at this, all right? If this is working for you, awesome. Another way to look at this is this. What is the biggest number that I can use to divide into 18 in 42? Okay? If it doesn't divide evenly without a remainder or a decimal, if it doesn't divide evenly, it doesn't work. It's not a factor. Okay? So look at 6. 6 will go into 18 evenly. And 6 will go into 42 evenly. Now, is it the only number that goes into both? No. But it's the biggest one that goes into both. Okay? So think, biggest number that goes into or divides into both. All right, let's look at one more here. 56 and 72. All right, so I'm going to write that on my board here. 56, and I already forgot what that other number was. 72. All right, 56 and 72. So we're going to do prime factorization here. Okay? I'm going to do 56, oh goodness, 5, 6, 7, 8. Got a little trick that I learned. 7 times 8. 7 is prime, so I'm going to bring it down. All right, 8 is not prime. It's 2 times 4. All right, 7's prime, 2's prime. 4, though, can be split into 2 and 2. Okay? And so my prime factorization for 56 is 2 times 2 times 2 times 7. So I'm going to circle that because that's kind of part of my answer. All right, now 72 is 9 times 8. And then I have 3 times 3. And I have 2 times 4 for 8. All right, and then my 3's come down because they are prime. My 2 comes down because it's prime, but my 4 can be split into 2 times 2. Okay, and so to write it neatly, I would put 72 is 2 times 2 times 2 times 3 times 3. And that's my prime factorization for 72. Okay, now for my GCF, I'll write it up here so you guys can see it a little bit better. GCF is the biggest number that goes into both 56 and 72. And I can look here at my common factors. Notice they both have a 2 in common. They both have a second 2 in common. I feel like I'm on The Price is Right. Gentlemen, do I have 3 numbers right? Yes, I do. I have 3 2's in common. That was for the parents, not probably the kids. Kids have no idea what I was talking about there. So notice the 7's not in common, the 3 and the 3 are not in common. So I've got 2 times 2 times 2 in common. So 2 times 2 times 2 is 8. I don't know if you can see that or not. There it is. So my GCF is 8. And again, I can test that by trying 56 divided by 8. All right? Just to see if that works. Let me just put my camera back over here. Can I do 56 divided by 8? Sure enough, it gets 7. Okay? And then I can do 72 divided by 8. And sure enough, it's an even number. Okay? So, quick way to check with your calculator. All right, so basically the rest of this page is the same idea. You're going to do prime factorization of each of those two numbers and then see what they have in common, the biggest factor they have in common. Okay, whoa, I just zoomed in and I didn't mean to. Okay, sorry about that. Now, section B says write the prime factorization for each number. Same first step. Okay, then determine the least common multiple. Okay, now the worked example goes a little bit of a different direction. Okay, and personally, I'm okay if you guys go this different direction. If you want to keep doing prime factorization, you are welcome to do that. Okay, but what they're doing is what we call skip counting. Okay, you've probably done this before, counting by 3s, 3, 6, 9, 12, and so on. Okay, 2, 4, 6, 8, stuff like that. 5, 10, 15, 20, 25. Skip counting. All right, and this isn't erasing very well. Oh well, we'll figure something out. All right, so if I skip count, for example, 28, the first number is 28, and then I add 28 to it again, and I get 56. And then I add 28 again, and I get 84, add 28 again, and add 112. Or I could do 28 times 1, 28 times 2, 28 times 3, 28 times 4, and so on. And you go on until, maybe 3 or 4 or 5 or 6 numbers, and then you do that with 32. 32 times 1 is 32, 32 times 2, 32 times 3, 32 times 4, 32 times 5, and so on, until you see one that overlaps. Because what we want is the least or the first, the smallest common multiple. So when you see a number that overlaps, that is the smallest number that is common as a multiple. Now let's talk about what a multiple is. Okay, like I said, if I take 28 times 1, I multiply 28 times something to get another number. I multiply 28 times 2 to get 56. These are multiples of 28. So when we talk about skip counting, we're talking about multiples. Okay, so find the smallest number that has them in common. Okay, now the other way to look at this LCM is what's the smallest number that can be divided by both of these numbers, 28 and 32. Okay, 224 can be divided by, what was the first number? Forgot it again. 28, sorry. My students are used to this. Parents, yeah, this is what your kids have had to put up with all year. My clumsiness and my forgetfulness. Okay, 228 divided by 32. That wasn't it. What was it? 224. Ah, rats. 224 divided by 32 is also an even number. Okay? So do you have to do all that with a calculator? No, but it is a way to check to see if you got the answer right. Okay, so let's do 40 and 100. Guys, I'm going to do the skip counting. Okay? We could do the prime factorization. I'm giving you guys permission to kind of skip over that aspect of it. Okay? So we're going to do 40. So the first factor, or sorry, the first multiple of 40 is 40, and then 80, because I'm adding 40 and 40 to get 80, and then it's going to be 120, and then 160. I'm going to stop there. I mean, I could go on for a very long time, but I may not need to. All right, we'll see. 100. First multiple is 100, then 200, 300. Uh-oh. I think I need a few more up here before I can start seeing where they go together. And I'm sorry, I should probably have it on this screen so it's a little bit easier to see. Okay? All right, so I'm going to need to go and get some more numbers over here. So 160 plus 40 is going to be 200. Ah, and look at that. That's the first number that they both have. Okay? So that is going to be my LCM. My least common multiple is 200 because they both have 200 in the list of multiples, and it's the first one. Now, are they going to have other numbers that overlap? Sure. All right, but are they going to be smaller than 200? No. And here's the last test. Can I divide 200 by 40? I can. Can I divide 200 by 100? Yeah, sure can. So this is a logical answer. All right. So guys, that is what you will be doing on the rest of this page. Okay, and again, I'm fine if you do the skip counting instead of the prime factorization. All right, thanks for watching, and soon I hope to post another video for the next page, and then we'll just kind of go on page by page together. All right, thank you guys for watching. Bye.